Hey, in this one I'm going to show you a library that I started using at work to serialize and deserialize structs from C++. So if you're familiar with Rust or Python, you might have probably used Pydantic or Serde, which I used in previous jobs, and I was really missing that in C++ until I found this library called reflect-cpp, which basically does the exact same thing, but in C++, which I found kind of impressive because C++ has a lot of metaprogramming capabilities, but they're a bit, I don't know, how do you say, obscure, I guess. So yeah, it's quite impressive. The way the library is built is quite intuitive as well. So let me just show you a quick example. So here I have a little main with a struct person, and I just create a person. And if I want to serialize that to JSON, well, I have to include the reflect-cpp JSON header. But all I have to do after that is to say reflect write no JSON write, and I specify what I want to serialize, and then it will just put it into a string for me. So let's end that quickly, place in string, like so. And if I run it now, you will see that my struct has just been serialized to JSON, and I had nothing special to do, just call a function, and it did all the rest for me, the parsing of the struct and so on, and the types. And so yeah, let's go from there. Let's now do the other way around, the deserialization. So let's just create another scope so that we keep both of them in there, and I can have my JSON string duplicated. Let's create a multi-line string just to make it a bit more readable. That's just the equivalent of like the Python triple double quote. Triple double quote. That's a very very nice thing to say. So let's just basically copy paste what I had here. Boop, like so. Let's put it here. And now of course, when you deserialize, there can be, well, the input, you don't know what it is, so there can be mistakes, so it won't always work right away. So you have to call JSON read now with the JSON string, and this will return you a result, and so you have to check if the result is not valid, if there is an error, let's just print the error. And so this is how you do that. You just call the error member function, and you call what on it to get the error message. Otherwise, it has deserialized it successfully, and you can just say, I don't know, person name, that's all. And this would just be the reference of result, and we'll access the name thing. So basically, you can get the person like this. And so that's how you get the person back from deserialization. So let's run that. So what did I do wrong? Yeah, of course, as soon as you use this read const char no matching function, let me quickly pause and see what was wrong. Yeah, of course. So in this case, for the write, when you pass the p object, it knows the type. It knows that this is a type person. Here, I didn't specify that I want a person. So yeah, you have to specify what you want to deserialize. That's pretty obvious, but just a slight oversight. Small oversight on my end, and you see it works. So it was able to parse this string and give us the name and put it all back in a struct person. Of course, maybe let me demonstrate a bit the error thing. So if I miss a comma, for example, it will tell me that it's an invalid syntax, could not parse document, expected something. If there is a key missing, so I replace age with foo, it will say age is missing, age not found. I think by default it does authorize that there is unknown keys. So if I create some random other keys in there, it will still work. You can disable that if you want with another feature of reflect-cpp. So and it supports a lot of other types. So for example, let me create job title enum like this, and we will say software engineer like so, and just I don't know CEO and plumber like so. Why not? And now we will have a job title enum, which will say job, and here we will need to specify a job title as a software engineer like so, and so this now will contain the software engineer, and we see that job is not found, so we need to add here that it's a job, and the job is software engineer like so. And now the deserialization will work as well. It will obviously check that the enemy member is correct. So if I put some random string in there, it will fail to parse. Yeah, like this. I mean, the error is very strange as to why, but I mean, you see what I mean. So yeah, it also understands std optional. So let's say height will be the std optional. So if I don't specify it at all, this is valid. So it will just say that the optional is null. But if you specify it, it will just it will put it in the serialized output, like here height is equal to 42, and of course the deserialization also understands this. So you can have a height key, but also not have it. It understands all the most of the containers from the standard library. So if we say a vector hint, I don't know, bench PRs, why not? You can then have 1, 2, 3, 4, something like this. And this also understands like so. Let's have a list in the JSON as well. So yeah, this is becoming slightly unreadable, but first job software engineer. So, but yeah, you see that the vector was serialized and deserialized without any issues, and that works with map, an ordered map, set, and so on and so on. It also works with std chrono a bit, like the durations. They understand it, and they have all kind of compatibilities like this with all kinds of types. Another cool thing I wanted to show, because this is maybe, well, I should have shown this maybe at the start of the video, but you're not limited to JSON. JSON is just maybe the most common one. But the great thing about this is you can switch between serialization and deserialization format like very, very easily. So let's say now I want to serialize and deserialize my stuff in Seaborg instead of JSON, which is just like a, I don't know, binary version of JSON, kind of. Now all I have to do is replace this JSON here by Seaborg, and now this will work exactly the same, except that the serialized output is now Seaborg. So yeah, and that was like replacing 4 characters. So yeah, that's pretty epic. They also support, if we go in the, I'm not sure, supported formats, that's it. They support all these formats, so you see that, for example, I also use the TOML format just for my configuration files. This is quite nice. They have CSV and Parquet files if you want to, you just have a struct like this, and this will be one row of your Parquet file. And yeah, you can see it's pretty complete. They also show you how to have a custom format. If I go in the documentation, there is a lot of stuff I haven't talked about, like there is the processors, which I mentioned but didn't show. So for example, you have a, maybe this is too small. You can add in your right a processor. So for example, this will convert all the snake case keys to camel case. So that's nice if you have from, for example, Rust to well, not. For if your C++ code uses a snake case, but your JavaScript code wants a camel case, you can do it like this. And this is actually done all at compile time, so this is quite nice. There is all kinds of stuff like there's one to put the default value if it's missing from the string that you want to deserialize. What else is there? You can flatten a struct, so if you have some kind of inheritance, not really, like if you want like to have a struct inside of another one, you can flatten it and it will, instead of saying a person and then create an object, it will just put all the fields right away, like so. What was another useful one? I'm trying to think. Oh yeah, the tagged union. That's a very important one. So in this example, they show that, sorry, I'm becoming a bit lazy. I'm just going through the documentation and quickly showing a bit like the cool features because I don't want to bore you and rewrite everything. But so, for example, this is no, this is variant. I want to go to tagged union. I mean, they're basically the same, but tagged union is a bit more efficient. So let's say you have multiple structs, and it's kind of like Rust enums. So you say, I want either a circle, a rectangle, or a square, and they all have different fields according to what type it is. And so you can just create a tagged union, and it will have a special attribute like this. And then you can say it can be either this, that, or that. And once, let's say in this case, they serialize a rectangle, and what you will end up with is that you will have the fields of a rectangle, but you will also have a thing that says this is this type, so the shape is a rectangle, and you will be able to deserialize it very easily. And when you deserialize it, you will need to do some very strange C++ thing. This is the visitor pattern, which is I don't know, it looks a bit scary, but basically you just say, if it's a circle, do this, if it's a rectangle, do this, and so on and so on. And I think that's about it. Yeah, they have all kinds of, you can, how do you say? Like you can modify one specific field with something like that. So for example, in this case, they just rename the field, so it's first name, and they want to rename it first name in camel case, but you could say foo or whatever. This is one of the ugly thing about reflect-cpp. One of the only ugly things, I think. And I think they just have no choice because C++ doesn't have the nice decorators of Python, or the nice I don't know how you call them in Rust. The macro things in Rust. You know what I mean, the hashtag square brace thing. And so they kind of have to do this, and then when you want to access it, you have to access it with get, or the parenthesis operator, which is slightly ugly, but it's not too bad. So yeah, for example, they show you that you can also skip a field if you want it to just be in the C++ struct, but it doesn't have to be in the output, some things like that. They also have all kinds of stuff for you can have a timestamp and specify the format of your timestamp, or you can what was an interesting one? I think that they have a whole validation thing, which I can't find right now, but basically you can just say, like, the minimum value is 1, the maximum value is 10, or you can have custom validators and so on and so on. So anyway, I think I will stop for now because this is already a bit too long of a video. But you see my point, this is a really nice library, and I think if you have a message queues and you need to serialize, serialize your C++ structs to communicate with other applications and so on, this is a really nice way to do it. So I hope you learned something. I hope you will try it out, and I hope your serialization and deserialization become smaller, and everyone's happy. And I'll see you in the next one. See ya.